guys, welcome back to day 11. Today we're going to talk about functions and domain and range. So a relation is a set of inputs and outputs. And relations can be represented in four different ways. So we first look at our first example here. This is a mapping. Okay, and you've seen this before, okay, where the inputs are on the left side and the outputs are on the right. And you notice a little arrow pointing to an input of 0 has an output of 2, an input of 0 can have an output of 3, an input of 5 has an output of 4, and that's how it's read. Okay, we've also looked at tables before. Okay, so the table. Okay, again, the inputs and the outputs are the corresponding, the input and the corresponding outputs are listed. Okay, we've seen it before as ordered pairs. Okay, where we have our x value and then our y value. So your input is your x value and your output is your y value. And then we've had graphs, okay, and the ordered pairs are represented on the graph. So in this case, the x-axis and then the y-axis. So this point right here would be an x of 1 and a y of 0. Okay, this would be a 1, 2, 3, 1, 2, 3. This would be 3, 3. So we're just taking the ordered pairs and putting it on a graph. Okay. So we're going to learn today that a function is actually a special type of relation in which each x value has only one y value. All right, what that means is if you look at the first mapping, notice that we have the inputs, we have 2, 4, 6, and 8, and then we have our output, 2 goes to 3, 4 goes output to 5, 6 to 7, and 8 to 9. So this would be considered a function because each x value has only one y value. Okay, and that's going to be different from number 2. Number 2 is not a function because if you notice the input of 1, it goes to 5 and then it also goes to 8. Okay, so you can see that kind of double line. Whoops, let me erase that. You can see that double line. 1 goes to 5 and 1 goes to 8. So as soon as you have that happen with any input, the whole thing is considered not a function. So we're going to say that 1 has 2 outputs. Okay. Number 3 is another table. It's just shown a different way. Okay, so we have our inputs, our x's, and our outputs are our y's. So our inputs are 1, 2, 3, 4, and 5. Notice they're all different. As soon as they're all different, I can say it is a function because it doesn't matter what the outputs are because I have all different. There's no way I'm going to have an input go to 2 different outputs. Okay, so and if I look at number 4, I have a 1, 1, 2, 3, and 4. And at first glance, I think, well, it's not a function. But if you look at the outputs, 1 has an output of 0, and then 1 has another output of 0. It's the same thing. So it still is considered a function. Okay. Now, if I had something like this, if I had x, y, and maybe I had 1, 0, 1, 1, 2, 3, 4, 5, something like that. This would not be a function because your inputs of 1 would go to 0 and 1, so that would not be a function. Okay. All right, so now looking at example number 5, I've got a 4, a 0, a 1, a 7. So that actually would be considered a function because they're all different. Each input has only one output. But if I look at number 6, I've got the 5, -2, -7, 1, 4, -7. Okay, this -7 has an output of 15. This -7 has an output of 2. So this is not a function. Okay, and it's not a function because -7 has 2 different outputs. Okay. All right, let's look at number 7. So looking at the graphs, we can determine if a graph is a function. We use what's called the vertical line test. All right, so what I mean by that is if I draw a vertical line through each one of the points and I only go through one point, then it passes the vertical line test and it is considered a function. Okay, so if you notice, there's no points that if I start here, there's nothing above it or below it. Okay, I could draw a vertical line and never go through more than one point. Okay, so that passes the vertical line test, so we would classify this as a function. Now, you can see the example in number 8 right here at x is 2, okay, an input of 2 has an output of 0, so that 2, 0 point, and then an input of 2 has an output of -3, okay? So the same input has two different outputs, and what happens is when you graph it, they're vertically right on top of each other, so if you drew a line, you go through 2 points, so it fails the vertical line test, so this is not a function, okay? Number 9, you've got a line, and a line is made up of an infinite number of points, but the points are right next to each other, so it doesn't matter if I drew a vertical line, I'd never go through more than one point. So a horizontal line is a function, okay? But that's going to be different than a vertical line. So let's look at this is number 11 here, okay? In this case, a vertical line, you can draw a line, obviously, okay, through more than one point. So this would not be a function, okay? So it's not a function or just no, okay? All right, if we looked at number 10, if we drew vertical lines, these actually approach the x and y axis, but they never quite touch it. It keeps going in closer and closer and closer and closer, but it will never touch it. So this is considered a function. Okay, and then number 12, when we look at number 12, we can quickly see that we can draw a vertical line and go through 2 points. Okay, so as soon as we can do that even once, it's not a function. Okay, so looking at the domain and the range. So the domain is the set of all of the inputs of a relation, and the range is the set of the outputs of a relation. Okay, so your x values are your inputs, and that would be your domain, ZID. Your range is your outputs and your y values. Okay, that's one way to remember it. I prefer my silly acronym. I call it Dr. XY. Helps me remember my domain is my x values, my range is my y values. Okay, if that helps you, then you can use that. Okay, because domain and range are just kind of two unique terms, but they do mean it's very important. So the domain is the inputs, range is your outputs. Okay, and that range is different than the range that we use in statistics, okay? So it's a little bit different. All right. Okay, so we're going to use the information provided to determine the domain and range of each relation. Then we're going to decide if the relation is a function. Okay, so once I look at number 13, I can see that my domain, let's change the color. Okay, my domain would be all of my input values. So it's going to be the set of the numbers 0, 5, and 10. Okay, so right here, those are my inputs. My output or my range, okay, would be 2, 3, 4, and 5. Okay. All right, notice your 0 goes to 2 and 0 goes to 3, so it's got two different outputs. So as soon as we determine that, we know it's not a function. Okay, when you list your domain and your range, you're going to put it in the set notation, okay, and you're going to make sure you don't duplicate any values. You typically list your values or your elements. We like to call these elements of the set, okay? We list them in ascending order from least to greatest, okay? So this is a set of different elements. All right, number 14. Okay, the domain is again our x values. So we've got 0, 1, 4, and 6. And the range would be 0 to 8 and 12. Okay, and because every input has only one output, this would be considered a function. So yes, function. All right. And this is not a function, and the reason was because 0 has two outputs of 2 and 3. All right, now let's look at 15. Here we have our domain. Okay, domain would be the set 1, 2, 3, 4. Oops, I'm running out of space. Oops, let's do it down here, 1, 2, 3, and 4. All right, and the range would be the set of elements 0, 1, and 2. Okay, so in this case, each input has only one output. It's okay if they share the same output. Notice 3 goes to 2 and 4 goes to 2. It is still classified as a function. Okay, so it's only the x's that you have to worry about repeating. All right, functions can be represented by equations. All right, this f with the input of x is read as f of x. This would be g of x. This would be h of x. Okay, whoops. All right, so y equals 2x minus 3 is the same as f of x is equal to 2x minus 3. Okay, the function only works when the output is the same for the given input. Okay, so it says, what is the range if the domain, so remember, domain range, Dr. XY, so your domain is your x values. So it's saying y equals 3x plus 2. We know the domain is given, it's our x values. All right, so we have this element -2, -1, 0, 2, and 5. Okay, the function we have is y is equal to 3x plus 2. And then our output would be our y value. Okay, so we're just going to plug these in and populate this table. Okay, when we do that, our y is equal to 3 times -2 plus 2, which is -6, plus 2, which is -4. Okay, so our output would be -4. Here we would have y is equal to 3 times -1 plus 2, which would be a -1. Then we have y is equal to 3 times 0 plus 2, which would be a 2. And then we have y is equal to 3 times 2 plus 2, which is going to be 8. And then y is equal to 3 times 5, whoops, 3 times 5 plus 2, which would give us 15 plus 2 is 17. Okay, so it says, what is the range? We know the range we're looking for the y values. So the range would be the set of elements, okay, starting at -4, -1, 2, 8, and 17. That's how we'd get that. All right, so just a little lesson on domain and range. Thank you. Bye-bye.